started then. We are
Can you just write this on the floor? Find the option.
sorry. Okay. We are starting over with question 1 at the very bottom of page 1. Okay. So what you are looking at is something which we didn't cover all that much here. I'll definitely keep that in mind if this shows up on your actual test. We didn't actually go over this all that well, or at all, really. But this is the concept of differentials. And the basic idea is that you can take that dy dx and you can separate that into 2 component pieces. Okay. It really is like something called dy divided by something called dx. We don't know what the dy and dx means. It is kind of related to slope, but not really slope. So we start off with this equation right here. gt equals 1/4 t cubed plus 16 over t. And first part is they give you t and they give you a differential value for dt, and you're supposed to find the value for dy. And that turns out to be not that difficult. If this is my y, then you just need to find the derivative to get dy dt. After you've found your derivative, you can solve for dy simply by multiplying the dt over to the right side, which is something which we should get used to doing. Multiplying that dt to the right side and isolating the dy is going to prove very useful next week, really. Okay, so we've done that. We have values for t. We have values for dt, and that should turn into this result right here. Negative 13.227 for dy. It's really just an algebra problem, right? Not much more to it than that. Part B, this is where we need to get going. We need a tangent line approximation at T6 to estimate G of 5.3. So this is where work happens. Part B, you know that G of 6, we calculated that. Do you remember what that calculated? 170 over 3? That's 170 over 3. And G prime of 6, that's going to be equal to, what is that, 3/4 of 6 squared minus 16 over 6 squared. And let's get a few minutes to calculate that. Maybe I should calculate that too.
Wouldn't it just be 13.277 times 2?
No, because times negative.
Okay, I'm going to quit over to the home screen. I'm going to start typing things out. Let's see, what do we got? 3/4. Let's get that fraction key. I mean, this is 2015. We have fraction keys. We have 3 over 4 times 6 squared minus, again with the fraction key,
Which one is the fraction?
16 over 6 squared. And what's nice about this is I should get a rational answer. Yes, 239 over 9. That's going to be my slope, 239 over 9. Okay, so we have everything we need to make our tangent line. We have an x-coordinate, which is 6. We have a y-coordinate, which was, is that 170 or 190? 170 over 3. We have a slope, which is 239 over 9. And so the correct way that you're going to want to write this is g of x is approximately equal to y, which is equal to slope, 239 over 9, x minus 6, plus 170 over 3. Therefore, g of 5.3 is approximately equal to 239 over 9, 5.3 minus 6, plus 170 over 3. Okay, go ahead and calculate that. I'm going to calculate it with, just to kind of show you what I would do if I was to do this. I just put the whole thing in one line. I really recommend you do that. What was my slope? 239 over 9? Over 9. 5.3 minus 6. Gosh. Plus 170 with 170 over 3. Okay. So we got the entire thing in line. This is a really nice thing to do because if you mistake, you can see the entire calculation in one view. You don't have to keep scrolling and looking for ANS and what does ANS mean? Where does this one come from? You just one screen, you know where the mistake is. Highly recommend you compute everything like this while calculus. 38.077. Let's screenshot that actually. Okay, so G 5.3 is approximately equal to 38.077. I'll put that other 7 there to remind me that I could round if I wanted to. I'm not going to lose points if I don't round. And that's the end of part B. Questions? Yeah, I can.
You don't have to put the things.
You do not. We're going to stop reading after that 37, or the third digit.
So for the test, how many decimal for like all the answers?
Answer is always 3 decimals.
It's minus multiple choice.
Okay. Any more questions? Okay, so buckle up. We're going to do question 4.
Wait, there's a part C.
Oh, there's a part C. So don't buckle up yet. You can unbuckle. Second derivative, why is that an under approximation? This is a pretty advanced question. So tell me about g of x. What is g of x equal to? Yeah, that's good. G prime x. Okay. And then g double prime of x. 6/4 is 3/2, yeah?
I didn't know.
3/2 t.
Plus 32 over t.
32 over t cubed. Now we can actually look at all this. What is g of 170 over 3? What is g prime of 2? Was it 290? Don't remember. G prime of 6. 239 over 230 over 9. 239 over 9. G double prime at 6. Let me know when you have an answer.
247 over 27.
That's good. Okay, so what does this tell us about the shape of G? What's the first thing we know?
Positive slope and it's concave up.
Concave up, positive slope, right? How do we draw a function that's concave up and has positive slope? Is it going to go this way or that? First one, right? Because it's increasing.
Yeah.
Is it going to do this or is it going to do this? Concave up, right? So it's got to be the first one. So in other words, g of x at g of 6 is going to be kind of like that. Okay. Let's look at a tangent line. Any tangent line there it's increasing, concave up. So the question is, tangent line under approximate or over approximates? Is the y value greater or less than the actual value? The actual value is a black line, right? The tangent is the red line. So are the values on the tangent greater or less than the actual value? it's got to be less, right? It's below the actual value. Did it matter if I was on the left or if I was on the right? Doesn't matter. As long as I know the function is increasing and I know that the function is concave up, I know that this is going to be an under approximation. Okay, so what's the question now?
Compute the error.
Is it an under approximation? Yes, it's an under approximation. Why do I know this? The tangent line values are less than the actual values. All right, so now it says to give the error of approximation, right? Okay, so this is a little bit new for you. The error to actual minus the estimate. Don't know if you ever used it like that before. Let's figure out some things. My actual value, what is my actual value? It is, is that 1/4? Um, hmm? Yeah. Okay. 170 over what? Not 6, 5.3. 5.3. That's 1/4 of it's t squared, right? T or t cubed. Cubed. Plus, what was that, 16 over 5.3? Actual value right there, 40.238. Predicted value again? 239 over 9. 239 divided by 9. Oh, 38.0. You're right, you're right. There we go. So it's 40.23811. And minus, what was that, 38 point? Hang on, my computer just took a dump. 0.777, right? And what's the error? That's enough. That's my error.
you do fractions, so you get a little.
What do you get?
2.60222.
0.222. Okay, and that takes care of number one. Questions on that?
We're plugging in values in our calculator.
Yeah.
We use values that we already did.
Never do it. Never do it. Yeah, use the original. Good question. I'm glad that comes out now. Okay, now we're going to buckle in. Now we're going to look at that question. Now's a good time to check and make sure I'm still broadcasting. You're still broadcasting. All right, so here's that number 4 I promised you. Question 4, utility. Hello? Okay, so company wants to deliver gas from the source S to a plant across a river that's 3 miles wide. It costs $4 per foot to lay pipe into the river, but only $2 per foot to lay pipe on land. What is the cost of laying pipe in terms of U? Yikes. Okay, so let's just make sure that we're clear. The pipe is going to go from S to T, and then the pipe is going to go from T to P. So what is the distance from S to T? Sure, the pipe is going to go from S to T across the river. From T to P on the land. Okay, so we're going to take however long from S to T, multiply by $4. Then we're going to take however long it is from T to P, multiply that by $2, and that's going to be the price of the pipe, right? So let's figure out what is the distance from S to T? How do you write that in geometry? That ST, the hat on it, or just leave it alone? Hat or no hat? No hat, right? Distance ST is equal to square root of 9 plus U squared. That's great. And so the cost underwater, that's going to be equal to that distance multiplied by 4, right? No, hold on. $4 per foot. This distance is in miles. Feet, which is equal to 5,280 times 9 plus U squared miles, right?
Where do you get 9 from?
3 squared. See the right triangle?
Yeah.
That's a conversion from miles to feet, or from feet to miles. 1 mile is 5,280 feet. Wait, do I need to divide? Oh, this is in miles. I'm sorry, this is miles. This is feet. Does that look good? So the cost is going to be this multiplied by 4. So 4 times 5,000 is 20,000, 28,000. I can't do this. 20,000, 28, 2960, 20960.
You're putting 4, right? Plus 9, 5 times 5.
Okay, that good?
So you've already multiplied 5,280 by, we've had 9 plus square.
This is in miles here, and we need to know in feet.
Oh, so that's the number for.
That's a conversion for feet, yeah.
Are we gonna, like, be expected to know that on
You should know that one, right?
miles?
I didn't think that was unreasonable, is it?
Sort of.
Sort of?
Like, I know it's in the 5,000, but I would have said 5 to 80. Maybe.
So, can I ask a side question? So if you know the volume of a sphere, a cone, a cylinder, and the surface area for the sphere, is there anything else that we should know?
We should be able to figure out surface area for us for cone, right? And for a prism and for
With surface area or volume? Oh.
Surface area, optimization, and volume is very related.
you should be able to know that stuff already. Okay, let's move on. How much is it going to cost over land? This will be a lot easier. What's the distance over land, which is v? Give me v in terms of u.
U plus V plus Y.
Getting there.
Oh, yeah.
Perfect. That's in miles, right? How many feet is that? Multiplied by 5280, right? 5 times 5280? 26400. Oh my gosh. Okay, there we go. Okay, at $2 a foot, how much money is this going to cost? The cost on land. Okay, 2, that's 52,800.
47.
Is that right? 5280
Yeah, 52800.
minus 10560. I forgot you.
Oh, that's
Wait, for the cost of the water, don't we need to? Oh, we multiplied it, okay.
4.
Let me know if that 10560 is correct. It is. Okay.
Wait. You put 10560U, but isn't it just 10560 without the U?
Why not? Why would you?
Because you multiplied the 2 already.
Yeah.
So what did you take out the U? To plus
I didn't plug in for you.
Oh, I see.
How are you doing? Nervous.
So you multiply the distance quantity by 10,560.
I multiply the distance quantity by 5,280 to get me to how many feet? And then I multiplied the number of feet by 2 to get me the amount of dollars. Because it's $2 per foot.
So you just multiply that or how many?
Mhm. All right, so if I put these two together, I should get a unit, something for the cost, right? The cost in terms of U is going to be equal to the cost in the water, which is 21,120 times root 9 plus U squared, right? Plus the cost on land, which is 52,800 minus 10,560 U. Okay, that is the cost, and I know it makes you nervous. This is probably the worst math problem you've ever done.
1503.17.
I don't know number is.
150,000. 503.17.
I don't know what that number is in reference to. You haven't asked the question yet.
Oh, I plugged it in and I got it.
But what?
I hit X. And I guess equal to 0. And no, I plug in X instead of U. It's just a variable.
But yeah, but what did you find it?
I don't know. Let me attempt it again.
How do you know to add them together?
Because remember what we said there, the cost of running this entire pipe would be the cost on land plus the cost on water. So the first thing we did was we calculated how much does it cost to put the pipe in the water. How much does it cost to put the pipe on the land part? Put it together. That's going to be the total cost. Okay, and then the rest of this is pretty easy, right? Yeah. Now we take our derivative and we look for criticals. I know you're so happy to take a derivative of this. Sure. The derivative of cost, C prime, in terms of U, K. So what's half of 21,120? 105, 10,560. So you should do. I should not. I should do this slowly. Yeah. I should do this slowly. We got 21 times 1/2 times 9 plus U squared to the times 2 minus 10,560. That's great. C prime of U is then going to be equal to 21,120 divided by the square root of 9 plus U minus 10,560. Thank you. Thank you. Okay, we have a derivative. What do we do now? Critical. How do I do that? I don't have a numerator yet.
Oh, it's on denominator.
Common denominator now? Hmm? 21, 120 minus 10, 560 root 9 plus u squared, the entire thing over root 9 plus u squared. You know what's nice about the denominator? It will never be equal to 0.
Yeah.
Can you tell? Could you set it equal to 0 real quick? There you go. The denominator will never be equal to 0. So you just have to worry about the numerator. When is, so we're looking for critical numbers, right? Critical, when is 21 u minus 10, 560 root u squared, when is equal to 0? Three? Radical three? That's radical three, isn't it? How do you solve this? Solver. Good. Solver. Let's look at solver real quick. You should be really excited about using solver. Should be so incredibly. Somebody, we got 21, 120, and u, right? Can I put a u there? I could put u there if I wanted to. Why? Why not? Minus 10, 560 square root of 9 plus u squared. Nine plus u squared, good. And I want that to be equal to 0. And here we go. Here's some advanced calculator method for the solver, okay? Now, look where this is bound. That basically tells the calculator where it should look for the answer. Now, you could say the answer must be between negative 1e99 and positive 1e99. Let me back up for a minute. The calculator does not have an infinity sign. Okay. When you see 1e99, that's basically the biggest number the calculator can do. 1e99 is 1 times 10 to the 99th power. So what you're seeing is, you're saying to the calculator, where you should look for the answer somewhere between negative 1 times 10 to the negative to the 99th power and 1 to the 99th power, or 1 times 10 to the 99th power, which is this huge, domain for the calculator to look through. You can make the calculator's life a little bit easier, and actually your life a little bit easier, if you already know the domain of u. You already know the domain of u. 0 to, look at your diagram, what's the biggest u can be? It can approach 5, right? It will. The biggest it will be approaching 5. So the only trick here is you got to find the curly braces. I'm going to give you a minute to look for the curly braces. Yeah. So second curly brace 0 to second to 5. Second curly brace on the right side. So that tells my calculator I only want to look between 0 and 5 because I know there might be more answers, but they're irrelevant to me. Alpha enter. That is root 3, isn't it? Alpha enter. Alpha enter. 1.732. Real talk. Is this a minimum or a maximum? How about this? Is it a maximum? What would be the most expensive way to lay down this pipe? All the way through the water, exactly. And if it goes all the way through the water, what's the value of U? 5. That's not what we have here, right? We already know the maximum is going to be when U is 5. So this is not the maximum, meaning probably the minimum. Technically, I would tell you to use a derivative test. We don't have time for that. Okay. So U equals, the most economical way would be to have the, well, that's what it says there. Most economical is if the pipe is laid to across the river to a point 1.732 miles away from point R, i.e. U equals 1.732. So I'm not going to bother writing that out. It's on your answer sheet already. And okay, how do we feel? Yeah.
So like, what you were adding to.
It's actually really difficult to use this scroll down thing. Sorry. Here we go. Okay. Let's leave it for a couple minutes. Oh, the whales are starting in 40 minutes. The whales. It's going to be humpback whales and orcas and California sea lions and otters. Oh my God.
That was like a sports team.
Otters. They're otters. You know, my wife, like, she will literally crap herself when she sees an otter. It's really funny. Yeah. They're so cute. No, who's scared of an otter? You probably shouldn't be scared of an otter. They've got like mean teeth. They also wrap each other in seaweed so they don't lose each other. I learned that one. I didn't know that one. And then the blue whale. They found a blue whale. I can't wait. You know, I've never seen a blue whale in like alive. I've seen porpoises. Dolphins I've seen. Gray whales I've seen. Humpbacks I've seen. Never a blue whale. I'm in the blue whale stomach, I'm dead. Probably. Oh. 3 days. Okay, so we probably don't have time to do everything from 1 through 11. That's all we have left. We already did 3, 5, and 8. Yeah, so we should make a plan about which ones we want to prioritize. Number 2. Oh, we did that one. We didn't do it first period. Let's look at it then, okay? Let's look at that number 2. Here is that pen. You'll notice that we've labeled the horizontal side Y. So once you've done that, you can kind of put all the lengths together and figure out exactly how much fencing you're going to need. There are 4 X's and there are 2 Y's. So 4X plus 2Y is going to be your fencing amount. And that fencing amount is constrained. It has to be 1,000. If you know that, then you can solve and say that, well, if that's true, then Y has to be 500 minus 2X. That does not look like an X. Let me make that a 2X. Minus 2X. That's my equation for Y. The next thing is maximize the area. So let's get a function for area. Area is just the horizontal dimension multiplied by the vertical dimension. So X times Y, color-coded for your convenience. Substitute for Y. You know that Y is 500 minus 2X. And after you solve, you get that is 500x minus 2x squared. And let's remember that that's the area. It's the formula of the area. Next thing we're going to do, part A, or part B, we want to maximize f. So we can get a domain for x. We know that since this is an amount of fencing, x needs to be greater than 0, which is another way of saying the lower limit of x approaches 0. What about the upper limit of x? That approaches 250. So if you imagine, remember that you have 4 different fences of length x. And if length y is equal to 0, then you'll have x has to be 250. It'll never get there, but it'll approach there. Yeah. I purposely found the domain of x so that I could use the candidate test. I like the candidate test better, more conclusive, or it's easier to be conclusive about it. Are we okay with the domain? Sure. I know that x has to be bound by 0. But if you imagine the biggest that x could be, let's just go to the diagram first. Okay. I have 4 x's. Now, if I said x, the biggest x could be is 1,000. That would mean I have 1, 2, 3, 4,000 feet of fencing, which I don't have. I only have 1,000 feet. If x is 500, that's 500, 500, 500, 5. That's still 2,000. I only have 1,000. So basically, I'm dividing by 4. Or another way of looking at it is, what happens if y is 0? If y is 0, then the amount of fencing is just 4x. 4x equals 1,000, x equals 250. Okay? All right, so I have my domain. And now it's just a matter of derivatives. So f prime, 500 minus 4x. Set that equal to 0, and your critical number is 125. We have a domain for x, so we can use a candidate test. Here's our candidate test. We're testing the area at certain values of x. The first value of x that we try is a critical number. So when x is 125, we get an area of 31,250 square feet. The other two values that we want to try are 0 and 250. Those are the left and right side of our interval for x. For both of those, you get a 0. So you've been very consistent now. We know where the maximum has to be. It's got to be at a critical number or an impulse. We've looked at all the endpoints in the critical numbers, and we found that the maximum area among those is when x equals 125. So if the maximum area among my candidates is that when x equals 125, the maximum area for the entire values of x is also going to be when x equals 125.
Why are you not plugging it back into the f prime of x?
Right, because f prime of x tells me how much the f changes. In the candidate test, you're interested in what is the actual value of your function. Okay. So it's kind of like this. Candidate test, you plug into f. First derivative test, you plug into f prime. Second derivative test, you plug into f double prime. Okay? Lastly, to describe the dimensions of the pen, that will give you the maximum area. Well, when x equals 125, then y is going to be, I forgot, 250. $250.
Are you plugging that into the original x into the original equation?
Yeah, that's what I just said. Okay. Anything on number 2? We went over that pretty briefly. So. Good. Let's figure out which problems we want to do from 1 through 11. Which one? I heard a 6. I heard an 11. We did 5 already. 6. I heard 11. 10. You're welcome. We have 6, 10, and 11. No. 10 is a lot like the one we just did. So let's put that last if we need to. Anything else?
If we have time to do it again.
I'm not going to have time. I'm leaving at 5. Any other? Okay, so let's try these out in order. Let's try 6. We want a linear approximation to estimate f of 3.5. They give me an f prime. They tell me what f of 3 is. What is the equation of the tangent line? Okay. So for a tangent line, you're going to need 3 things. You're going to need an x-coordinate. You're going to need a y-coordinate. You're going to need the slope. So we got to figure all that out first. So first of the easy one is x-coordinate. The x-coordinate is 3. They gave that to you, right? Second thing is a y-coordinate. Again, they gave that to you, 1.5. And then the last thing is the slope. How do I get the slope? Plug into f prime, yeah. That's going to be f prime of 3 is 2 sine 9 plus 3 cosine 3. Let's get a number for that. Oh, what am I doing? 3 cosine 1.5, yeah. We have a number.
1.036.
1.036. That's not a final answer, is it?
No, yeah,
That's not the answer to part A, though, right? Okay, so we can't use. So we can't leave this at 3. We need a couple more digits.
448.
Okay, so that's my slope, 1.036448. Equation of the tangent line, then we just put those 3 quantities into y equals m x minus x naught plus. So y equals 1.0368 x minus 3 plus 1.5. Okay, that's part A, right? Part B, linear approximation. Oh, I should have the problem number here. This is problem number 6. Okay, part B. We want to put 3.5 into this. This is going to be approximately equal to 0.036448. 0.5 minus 3 plus 1.5. 0.5, 1, 6. 2.016.
2.01.
Zero. Okay. Any other questions on question number 6? Looks good? Yeah. Yeah.
I'm still kind of confused on when you go and use a candidate test versus when you need to use a person.
Other than just telling you which one to use, if you can figure out a domain for the independent variable, use a candidate test. You can't figure out a domain for that, or if the domain happens to be infinite, then you're going to have to use a first or second derivative test,
So like increasing, decreasing.
or concavity test.
That's first derivative and second derivative.
Yeah.
And then like maximizing problems. Is it first derivative also?
It's, most maximization problems can be done with the candidate test. Okay. Zero. Let's take a look at 11. A rope is attached to, oh yeah. A rope is attached to a boat at water level, and a woman on the dock is pulling the rope at a rate of 50 feet per minute. The woman's hands are 16 feet above the water level. How fast is the boat approaching the dock when there is the amount of rope out is 20 feet? I probably should reword that, right? Okay, so we have the boat here. That's the boat. Here are the hands. Okay, so let's get some idea about what's going on. The distance from B to H, is that changing or is that constant?
It's changing because you're moving it toward.
It's changing. So don't put 20 in there. Put a variable. Which variable would you like? You'd like Z, right? Good job. Z. Let's put Z there. All right, the distance from B to the right angle, is that constant or is that changing?
It's also changing.
Also changing since the boat is going inwards. Let's call that X. Good choice, X. Okay, the distance from point H to the right angle, is that constant or is that changing?
That's constant.
That's constant. Good. Let's put a number there. What is it? 16. Okay, I need an equation that will nicely put those three together. If you guessed the Pythagorean equation, you're right. Equations tell us that x squared plus 16 times 16, that's 100. Is that 256?
Yeah.
Is equal to z squared. Thank you, Pythagoras. You have helped me again for another year. What do we do first? No, we just want to know how fast the boat is approaching the dock, right? So we are down to a good number of variables. Derivative time, 2x dx. You know what I'm going to do? I'm going to do this. d dt of the left side equals the derivative of the right side. Two x dx dt equals 2z dz dt. You probably want to take care of those. Well, we want to solve for dx dt, right? This is a good place for the solver.
How do I clear this thing?
Push up. Push clear. Push up again. Sorry, put a 1 there. Now push up. Now push up.
Oh, okay.
Oh, do we have a value of x? Yep. You got the Pythagorean theorem. Good. It's 4, 5, 3, 12, right? Good. It's negative 50 because the length of the C is shrinking, getting smaller. I wouldn't be 100% confident that the negative sign is going to be inconsequential. It does happen to be inconsequential in this case, but it's better if you have a consistent method and you work with your consistent method. Four, 5, 25, 250 over 3. Feet per minute. Awesome. Question. This is very.
Or at least like one or would it be
I'm not going to talk about what the test is and is not going to be. I gave you this, and that should take care of it. Right. You're a big boy. You can handle the anxiety. Yeah. I'm going to be here in nutrition, yeah. Okay, we want to do number 10 and then we're done. And I'll only miss 15 minutes away. TiVo. See, the problem is, let me tell you the problem with Mrs. Ferreira. Mrs. Ferreira keeps the TiVo at 99 and 90 and 100% full, like literally 100% full all the time. Like, how are we supposed to watch? Yeah, but then she says, "Oh, I might want to come back and watch this fascinating program about." Yeah. No. Yeah. No. Her head will explode if I do that to her. It's not gonna happen. It's not worth it. Okay, you're building a pen to house goats in a ranch. You're using a barn and 3 sides of wooden fence. You want to enclose 1,000 feet for your goats. Sorry. Okay. So let's see. We got the barn. Luckily, I have red, which is a traditional color barns, even though I'm not sure I've ever really seen a red barn. Here's a barn. This is from a top view, okay? Barn. Something I've never figured out where the word barn comes from. Barn has to come from something, right? Yeah, right? So the word barn has to come from something. Another language? Possibly. Barn doesn't sound Latin. Barn. Hey. How you doing?
Well, I just
It's fine. My computer is like being slow now. So
it's like broken.
broken house.
Oh, yeah. They don't English is bird. Old English is bird. You supposed to see Barbie? I don't know why.
Here is my one of my fence. The fence only needs 3 sides, 2 of which will be X, 1 of them will be Y. The area of the barn, of the fenced-in area, is XY. And this time, we're saying we're going to enclose 1,000 square feet of goats. That's awfully cute, too. Oh, okay, so Y then is equal to 1,000 divided by X. We want to minimize the amount of fencing we use. So we're going to have to minimize the amount of fencing. How much fence do we use? F of that equals the number of amount of fencing. Can I get an equation for f of x? 2x plus y. Let's substitute x plus 1,000 over x. We want to minimize this, right? So derivative time. F prime 2 minus 1,000 over x. You want to turn that into a rational expression. F prime of x is equal to 2x minus 1,000 x. Gives you 2 critical numbers. X equals and x equals 0. Yeah. Oh. Isn't it? Oh, it is over x squared. It is over x squared, right? Damn it. Thank you. That means my critical number is wrong. Square root of 500, that's 25 times 20. 100 times 5, 10 root 5. I don't know if that's right, though. Okay. How do I know if that's a minimum or a maximum? Should be a maximum, right? Or a minimum. Minimum. This time, the candidate test actually doesn't work this time because I know x could be down below by 0, but how long could x be? Take a look at my diagram. How long could x be? Can it be 100? If x is 100, then y is going to be 10. Yes, it can. Can it be 1,000? If x is 1,000, then y is equal to 1. Can it be 2,000? No. If x is 2,000, then y is 1/2. What's wrong with y will be 1/2?
Because then it would be 4,000.
Can x be 100,000? Yes. Y would be 1 over 100. So in other words, there is no upper bound to this interval for x.
Also, okay, so that's why
That's why we're not going to use a candidate test this time.
it would be wrong.
Yeah, you wouldn't be able to get it. Well, you would be able to get an upper bound. You literally cannot do a candidate test. Okay, so we'll use the first derivative test. So since x is between 0 and infinity, cannot use candidate test. You can only use a candidate test if you have a finite interval. This is not a finite interval. Okay, let's go back to f prime. Why am I doing this again? You already have it. Okay, let's figure out our first derivative test then, right? First derivative test. X. F prime of x. We can go from 0 to 10 root 5. And then 10 root 5 to positive. Okay, let's get a number from 0 to 10 root 5. 1's a good one. 2 times 1 is 2. 2 minus 1,000 is negative. Something between 10 root 5 and infinity. 100. 2 times 100 squared is 20,000. 20,000 minus 1,000, positive. The denominator is always positive. Yeah. I think it's minus 1,000. Okay, so this says to us we have a minimum now, right? So we have a minimum. Minimum F area when x equals 10.5. By the way, if that x is 0.5 or 10 root 5, what's y? Hmm? 20 red 5? Yeah? Okay. What's part B? What are the dimensions of the pen? Oh, the minimum amount of fencing. Fencing used is that 2x plus y? That looks like 40 root 5 feet. Root 5 feet of fencing. Give me one. I'm gonna come right back to this. I'm gonna turn off YouTube. Oh wow.